All right, today we're going to start out with a little bit of a review from last week's lessons. So last week when we learned those limit laws, it gave us the limit, say, of f of x as x approached -2. But for these problems, we need to evaluate those limits first using the graph and then evaluate using the laws. So let's look at these graphs. Here's f of x and g of x. They're labeled for us. And let's start with number 8, where x is approaching -2. So we need to solve them individually first. So if I want the limit of f of x as x approaches -2, we're looking at this graph. So let me pause. Do I have a highlighter? Of course she doesn't. Okay, cute, really great. Here's a yellow pen. So if I'm looking at -2, here's the x value of -2. Good, you can see that really good, wow. Okay, so remember, limits is when your graph is approaching -2. If you were evaluating this for -2, your answer would be up here at 3. But because we're doing the limit, it's approaching -2 at a y value of +1. So the same thing for g of x. So we're looking at this graph. So -2, so an x value of -2 is right here. Well, here's where our graph hits. That's a y value of -1. Okay, so now let's take our numbers and plug them into our equation. So I'm going to take the f of x, we got 1, plus 5 times g of x, we got -1. So that gives us 1 minus 5, which is -4. Cute. Number 9 is still using the limit for -2, so I can use these same numbers. So f of x divided by g of x, that's 1 divided by -1, which is just -1. Okay, for number 10, we cannot use these same numbers because the limit has changed. It wants to approach +1 instead of -2. So let's take the limit of f of x as x approaches 1. Okay, ooh, let's change colors. So +1, x value of +1 is right here. That is a y value of 2. We will do the same thing for g of x. Okay, so now let's look at g of x as x approaches 1. Okay, so here's the x value of +1, but because it did not specify a side, if it was approaching 1 from the right side, our limit would be -1. But if it was approaching from the left side, our answer would be -2. Now, because those sides do not match, we cannot evaluate this limit if it does not give us a specific side. So this limit does not exist. We cannot answer this question. What should I put? Undefined? No. We won't give you a question like that. Okay. Moving on to our continuity for today. Okay, really simple, quick lesson today. You just need to be able to know basically some vocabulary here. This is not cooperating. Okay, your limits are either continuous or discontinuous. A continuous graph would be, let's see, any of these graphs, they're continuous from left to right. They have arrows to the left, arrows to the right, and there's no holes, no jumps, nothing like that. Now, the limits that we've been doing, these graphs, there's holes, there's breaks in the graph. These are considered discontinuous. So there are 2 types of discontinuities. There's removable and non-removable. Removable is when there's a hole in the graph. Okay, so it continues, nothing's crazy, there's just a hole. Non-removable is when you have to jump. So say you have an asymptote or you have a open and closed point and it skips a whole section in the range, okay? So if you're jumping, that's non-removable. If there's a hole, that's removable. Okay, great. Okay, so explain what it means if the limit as x approaches 1 from the left side is 3, but on that same graph as it approaches positive 1 from the right side, it's 6. What would that graph look like at 1? So let's sketch it first. So here's my graph. Here's an x value of 1. That's what our limit's approaching. Okay, our answers are 3 and 6. So what could it potentially look like? So I know from the left side, so coming from this direction, my graph ends up here at 3. So say that's happening. Cute. So from the left side, as it goes to 1, the answer is 3. But if it comes from the right side, the answer is 6. Now I cannot put another closed point here or this is no longer a function. So for this one, I'm going to put an open point and just draw some sort of graph to the right. So as it approaches 1 from the right side, the answer is 6. Either one of these could have been the open and the closed point. It does not matter when you're solving limits. It would matter if you're evaluating, but for this question, we're talking about a limit. Cool. So, is that all I asked? Cool. Okay, next. Okay, last part for today. Find the limit of f of x as x approaches 3. Prove that this function is discontinuous at x equals 3. Okay, remember, the two different types of discontinuities are a hole or a jump. So this function they gave us is a rational function. You have a variable in your denominator and a variable in the numerator. So I know rational functions have asymptotes and they could have holes. So going back to our direct substitution, if you plugged in 3, that would make the denominator 0. So your first step when you look at rationals is always to factor them. So I want the limit as x approaches 3. If you factor that numerator, it's x plus 3x minus 3. Difference of squares. And you still have x minus 3 in the denominator. So you notice that the x minus 3's can cancel, and you're left with just x plus 3. So the limit here, if I plug in a 3, is 6. However, it wanted us to prove that it's discontinuous. So now remember, lots of things to remember. When you cross something out, when you cross out factors in a rational function, that means there is a hole at an x value of positive 3, because that's the root there. And then going back to rational functions, to get the y value, you take the remaining function, so x plus 3, and plug in your x value. 3 plus 3 is 6. So for this graph, you have a hole at 3, 6. That's what makes it discontinuous, and you would have removable discontinuity because there's a hole. Okay. There's a Schoology assignment for you about discontinuity, and your next lesson will be over partial fractions. Bye.